Hello everyone, this is the video related to module 5 and module 5 is verification and validation of the simulation models. So till now in the different models like till the 4 models we have seen that we are going to build a simulation model or we are going to simulate a real system and we are going to check whether the given inputs and outputs are matching or no, and we also extract some of the inputs and also we give some inputs randomly and we go for checking with the outputs whether it is valid or no, and whether the system is working correctly or no. Once in the simulation model, where if the system is working correctly, then we go and implement it in the real time systems. So once the simulation model has been built, then we have to check whether it is built correctly or no, whether it satisfies all the conditions or no, whether it takes all the different types of inputs and gives the output according to our expectations or no. So all these things we are going to study in this module. So that is verification and validation of the simulation models. So first we begin with the optimization, that is model building. So in model building, the verification and validation process consists of the following components. So first one is verification is concerned with building the model right, and validation is concerned with building the right model. So here we can find the difference between the verification and validation. So model right and right model. So whatever model we are going to build, whether it is right and whether we have built the model right model. So this is nothing but verification and validation of the process or a model. So here there is a real system, conceptual validation, calibration and validations. Conceptual model we have, and in the conceptual model what we are going to do is assumptions on the system components, structural assumptions which define the interactions between the system components, input parameters and data assumptions. So once we have validated, then we go for the verification, operational model or computerized representation. So here first the real system, then we are going to validate the conceptual model, then we are going to verify the conceptualized model. So model building, it consists of the following steps. So first step is observe the real system and the interaction among its various components and collect the data on its behavior. So whatever real system exists to which we are going to build a model for it, then we have to interactions among its various components has to be checked first, and we have to collect the data, how it is behaving, what is the behavior of the actual system. Based on that we can collect the data and we can implement it in our model. Then second step is, once we have collected the data, then we have to go for the construction of the conceptual model, a collection of assumptions on the components and the structure of the system plus the hypothesis on the values of the model input parameters. So what are the input parameters which we have to consider, and also what are the components which are needed in order to interact between the different datas of the input model. So everything has to be constructed in this conceptual model in step 2. Then once we are ready with this, then we go for the step 3, that is implementation of the operation model. That is the third step is implementation of an operational model, that is the actual model which we are going to start with, usually by using simulation software and incorporating the assumptions of the conceptual module into the worldview and concepts of the simulation software. So these 3 steps are given here. So first step is a real system, conceptual validation, conceptual model, then go for the operational model. Then next, once the model has been built, then what we have to do is verifications of the simulation models. The purpose of model verification is to assure that the conceptual model is reflected accurately in the operational model. So first we will conceptualize the model, then we are going for the building of the accurate model or the operational model. So whether the conceptual model and the operational model both are same or no, both working are same or no, whether both are accurately equal or no, that will be tested with the help of the verification. The conceptual model quite often involves some degree of abstraction about system operations or some amount of simplifications of actual operations. Verification asks the following questions: is the conceptual model accurately represented by the operational model? Yes. If it is yes, then whatever it has been built, that is the operational model, it is verified. If it is not same, then it is not verified. We have to go for again for the changes, and again we have to go for the verification process. So many common sense suggestions can be given for use in the verification process. So there are many suggestions based on which we can go for the accurate model of the operational model based on the conceptual models. So we can see one by one. Have someone else check the model. So there should be some verifier or some expert person who can verify it, and he can verify and tell whether both are same, the conceptual model as well as the operational model both are same or no. That can be justified with the help of the verifier. The next step is make a flow diagram that includes each logical possible action a system can take when an event occurs. So that is step by step execution of the conceptual model into the operational model. So if any step is missing, then we will come to know where actually it is missing. Then again we have to go back there, and again we have to start with the implementation process. Then third is closely examine the model output for reasonableness under a variety of input parameter settings. So next step is print the input parameters at the end of the simulation. Make sure they have not been changed inadvertently. So what all input parameters we are made used in our simulation model, whether it may be a conceptual model or whether it may be a operational model. So in both we have to compare whether we are making use of the same input parameters or no. If any changes are made, then we can easily identify where actually what actually has been changed, and we can go for the corrections. So next is make the operational model as self-documenting as possible. So operational model, once it is getting ready, then the documentation process also should be carried out parallelly. So if the operational model is animated, verify that what is seen in the animation imitates the actual system. So here the operational model, if it consists of some animations, then we can check it with the actual system whether it is like the actual system or no. We can compare it. The interactive run controller or debugger is an essential component of the successful simulation model building. Even the best of simulation analysts makes mistakes or commits logical errors when building a model. The IRC assists in finding and correcting those errors in the following ways. So there is an IRC. IRC is nothing but it acts like a debugger, or it acts like an interactive run controller. So what it does is any model builder makes the mistakes, whether it is a logical error. So this IRC, it assists in finding and correcting those errors.